I want you to do something for me. Right now, wherever you are, I want you to lift your hands up in front of your face, look at them, take a deep breath, and then I want you to clap them together as hard as you can. Do it. You hear that sharp crack? You feel that sting in your palms? You feel the sudden, violent stop of motion? Your brain is telling you a very simple story right now. It is telling you that the skin of your left hand collided with the skin of your right hand. It is telling you that two solid objects met, touched, and stopped each other. It feels undeniable. It feels like the most basic truth of existence. Solid things touch other solid things. But I am here to tell you that your brain is lying to you. I am here to tell you that according to the laws of physics, specifically the laws of quantum electrodynamics that Richard Feynman helped discover, your hands did not touch. In fact, no two objects in the history of the universe have ever touched in the way you think they do. You have never touched your phone. You have never touched the ground. You have never touched your own face. When you clapped your hands just now, the electrons in your left hand and the electrons in your right hand got very, very close. They raced toward each other at kilometers per hour. They closed the gap to within a billionth of a meter, but they never made contact. Just before they collided, a force field, an invisible, indestructible shield of energy, sprang up between them. The electromagnetic force became so incredibly strong that it arrested the motion of your hands instantly. You are not feeling contact. You are feeling a field. You are feeling the magnetic repulsion of a billion trillion tiny magnets screaming at each other to stay away. If you are sitting in a chair right now listening to my voice, you are not touching the chair. You are hovering. You are floating on a microscopic cushion of electrons, levitating nanometers above the fabric, suspended by the fundamental forces of the universe. You are a ghost, floating in a world of ghosts, convinced by a trick of the brain that you are solid. Today, we are going to explore the great illusion of solidity. We are going to open the pages of the Feynman Lectures, Volume 1, Chapter 1, and we are going to ask the question that drove physicists crazy for 50 years. If atoms are 99.9999% empty space, why don't we fall through the floor? Why can't we walk through walls? To understand this, we have to stop looking at the world with our human eyes and start looking at it with physicist eyes. We have to look at the stuff we are made of. The atom. We all learn about atoms in school. You've seen the diagram in your textbook. It's usually a little cluster of red and blue balls in the middle. That's the nucleus. And then some black rings around it with little dots whizzing by. Those are the electrons. It looks cute. It looks compact. It looks like a little solar system. But diagrams are lies. Diagrams get the scale wrong, because if they drew the scale correctly, you wouldn't be able to see the diagram. Feynman asks us to imagine the true scale of reality. He gives us an analogy that breaks the mind. Imagine you have an apple in your hand. Now imagine you have the entire Earth. The size of an atom is to the apple. What the apple is to the Earth, that is how small we are talking. You have to zoom in by a factor of 100 million just to see the outer shell. But now, let's dive inside the atom. Let's look at the structure. Let's take that single atom, say a carbon atom from your fingertip, and let's blow it up until it is the size of a professional football stadium. Imagine the Superdome or Wembley Stadium. A massive echoing arena. Now we look for the nucleus. We look for the heavy part where all the mass is. Where is it? Is it the size of the field? No. Is it the size of a truck? No. If the atom is the size of a stadium, the nucleus is a single marble sitting on the 50-yard line. And where are the electrons? Where is the outer shell that defines the size of the atom? They are tiny gnats buzzing around in the very last row of the nosebleed seats, way up in the stands. And what is in between the marble in the center and the gnats in the stands? What fills the rest of the stadium? Nothing. Absolutely nothing. Void, vacuum, empty space. There is no air. There is no fluid. There is just empty geometry. This means that the thing you call matter, the thing you call solid, is 99.999999999% emptiness. If you took all the empty space out of the human race, if you squeezed all the nuclei of all 8 billion people on Earth together so that they actually touched, the entire human species would fit inside the volume of a sugar cube. That sugar cube would weigh billions of tons, but it would be the size of a die. Everything else, your body, your house, the planet, is just a puffed up illusion. It is a lot of nothing, pretending to be something. Now you might be thinking, that sounds like a nice theory, but how do we know? We know because we tried to shoot things through it. In 1909, a physicist named Ernest Rutherford did an experiment that changed the world. Before him, people thought atoms were solid blobs, like plum pudding, mushy, positive dough with electrons stuck inside like raisins. Rutherford decided to test this. He took a very thin sheet of gold foil, only a few atoms thick, and he took a gun that fired alpha particles. Alpha particles are heavy, fast, positively charged bullets. He aimed the gun at the gold foil. He expected the bullets to smash into the pudding and slow down, or maybe punch a hole through it. But that's not what happened. Almost every single bullet went straight through the gold foil as if it wasn't there. They didn't slow down. They didn't change direction. They just flew through the gold like a bird flying through a cloud. But every once in a while, maybe 1 in 8,000 shots, a bullet would hit something. It would hit that tiny marble on the 50-yard line. And because the marble is incredibly dense, the bullet would bounce backward. It would ricochet. Rutherford was shocked. He famously said, "It was quite the most incredible event that has ever happened to me in my life." It was almost as incredible as if you fired a 15-inch naval shell at a piece of tissue paper and it came back and hit you. That experiment proved the emptiness. It proved that the solid gold wall was actually a mesh of open windows with tiny, tiny wires between them. So here is the paradox. Here is the problem that should keep you awake at night. If I am made of atoms, and atoms are empty stadiums, then I am a collection of empty stadiums. If the floor is made of atoms, it is a collection of empty stadiums. When I step on the floor, it should be like tossing a handful of sand through a chain-link fence. The vast empty spaces in my foot should pass right through the vast empty spaces in the floor. My nuclei should miss the floor's nuclei. My electrons should miss the floor's electrons. I should fall to the center of the earth. I should be able to walk through walls like a ghost. Why don't I? What is stopping me? The answer is not matter. Matter is irrelevant here. The answer is fields. Feynman explains that what we call solidity is actually a war between forces. Physics tells us there are 4 fundamental forces in the universe: gravity, the weak nuclear force; the strong nuclear force; electromagnetism. Let's look at gravity first. Is gravity keeping you on the floor? No. Gravity is actually the force trying to pull you through the floor. Gravity is the enemy here. But notice how weak gravity is. Think about it. The entire Earth, all $6 times 10 to 24 kilograms of rock and iron, stretching 4,000 miles beneath your feet, is pulling down on your coffee cup. The whole planet is trying to hold that cup down, but you can lift that cup with one pinky finger. Your pinky finger defeats the entire planet Earth. That is how weak gravity is. It is the wimp of the universe. So gravity isn't the force that creates solidity. What about the nuclear forces? The strong force holds the nucleus together. It is incredibly powerful. It's what makes nuclear bombs work, but it has no range. It stays inside the marble on the 50-yard line. It doesn't reach out to the stands. It can't stop your foot from hitting the floor because it never leaves the center of the atom. That leaves one candidate: electromagnetism. The force of light, the force of chemistry, the force of lightning. Electrons possess a property we call negative charge. And the first rule of electricity, the first thing you learn in Physics 101 is, like charges repel. If you take 2 magnets and you try to push the north pole of one against the north pole of the other, what happens? You feel a resistance. You feel a springiness. The harder you push, the harder they push back. You cannot make them touch. Now apply this to your body. Look at your foot. The bottom of your foot is made of skin cells. Those cells are made of molecules. Those molecules are covered in atoms. And the outside of every single atom is a cloud of electrons. So the bottom of your foot is effectively a sheet of negative electrical charge. Now look at the floor. The top of the floor is also covered in atoms. It is also covered in a cloud of electrons. It is also a sheet of negative charge. As your foot descends toward the floor, gravity pulls it down. The atoms get closer. The stadiums begin to overlap. But the electrons in your foot see the electrons in the floor, and they start to scream, "Get away, we are negative, you are negative, go back." The force follows what we call the inverse square law, 1 µ(2). That means if you cut the distance in half, the repulsion doesn't just double, it quadruples. If you divide the distance by 10, the force multiplies by 100. As you get closer and closer, down to nanometers, that repulsive force skyrockets. It goes vertical. When you stand on the floor, gravity is pulling you down with a force of maybe 150 or 200 pounds. It is trying to smash your electrons into the floor's electrons, but the electric force pushes back. And the electric force is not just a little bit stronger than gravity. It is 10 barn per $36 times stronger than gravity. That is a 1 with 36 zeros. It is a billion, 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 billion times stronger. You don't need the atoms to actually touch. You don't need the nuclei to collide. You just need them to get close enough for that 1 billion, trillion, trillion multiplier to kick in. The repulsion becomes so strong that it balances your weight exactly. So you stop, you hover. The gap is tiny, maybe an angstrom or less, but it is there. You are floating on a sea of electric charges. You are surfing on a force field. But Feynman goes deeper, because Feynman is never satisfied with the simple answer. He says, wait a minute, if it's just repulsion, why can't I overcome it? If I get a hydraulic press and I push down with millions of tons of force, surely I can squeeze the electrons out of the way and make the atoms touch. It turns out you can't. There is something else making matter hard, something weirder, something quantum. This brings us to the Pauli exclusion principle. Wolfgang Pauli was a quantum pioneer, and he discovered a fundamental rule of the universe. The rule is, no two electrons can be in the same state at the same time. What does that mean? In the classical world, things can occupy the same state. If I have a bucket, I can put a rock in it. Then I can put another rock on top of it. They are just rocks, but electrons are not rocks. Electrons are waves. Imagine the electron not as a particle, but as a standing wave, like the vibration of a guitar string. When an electron is in an atom, it is vibrating at a specific frequency. It is singing a specific note. We call this its quantum state. The Pauli exclusion principle says only one electron is allowed to sing that note in this space. It's like a game of musical chairs, but there is only one chair for every person. Or imagine a parking lot with only specific parking spaces. Once a car is in the spot, no other car can park there. When you try to push your hand through the table, you are trying to force the electrons in your hand into the same space as the electrons in the table, but the slots are full. The electrons in the table say, I am already here. I am already singing this note. You cannot be here. To force them together, you would have to force the table's electrons to change their state. You would have to kick them up to a higher energy level. You would have to make them sing a higher, faster note. But doing that requires energy, an enormous amount of energy. Nature is lazy. Nature wants to stay at the lowest energy possible. So the electrons resist. They refuse to move up. They refuse to change their note. This resistance, this quantum refusal to share space, is what we call hardness. It is what makes a brick feel like a brick. It is what makes a diamond scratch glass. It is the reason that when a star collapses, it stops before it becomes a black hole. This is called neutron star pressure. It is the reason you are not a puddle of goo. So we have these two things, electrostatic repulsion, the force, and the Pauli exclusion principle, the rule. Together, they create the illusion of the solid world. This leads us to a fascinating question. If we never touch anything, what is feeling? What is the sensation of touch that you feel in your fingertips right now? Feynman explains that touch is just data processing. It is just information. When you press your finger on the desk, the electron clouds repel. This repulsion applies a force to the skin on your fingertip. Your skin is soft. So, the force field pushes the skin cells inward. It squishes them. Inside those cells, there are little biological machines called mechanoreceptors. When these receptors get squished, they open a little gate. Ions, electrically charged atoms of sodium and potassium, rush into the cell. This creates a spark, an electrical pulse. This pulse travels up the nerve fiber in your arm. It travels at hundreds of miles per hour. It goes up your spine. It goes into your brain. Your brain receives a signal, just a blip of electricity. The signal says, pressure detected at coordinate X, Y, Z, intensity high. And your brain, the great storyteller, interprets that signal. It says, I am touching something solid. It creates the sensation of hardness in your mind, but it is a simulation, it is a translation. You are like a pilot flying a drone remotely, feeling the feedback through a vibrating joystick. The joystick vibrates when the drone hits a wall, but you didn't hit the wall. The drone didn't even really hit the wall. Its force fields interacted with the wall's force fields. Your brain is the pilot. Your body is the drone. The force fields are the collision. This realization changes how you see the world. It changes the poetry of your life. When you kiss your partner, you are not touching their lips. You are interacting with their electromagnetic field. You are feeling the repulsion of their electrons against yours. It is a fusion of forces, not matter. When you hold a baby, you are holding a bundle of energy wrapped in a field of quantum exclusion. Feynman often talked about the beauty of this. He didn't think it took away from the romance of the world. He thought it added to it. He thought, how amazing is it that I can feel the texture of a rose petal, or the warmth of a fire, or the smoothness of a stone, when in reality, I am just a cloud of probability interacting with another cloud of probability. It means that connection is the fundamental interaction of the universe. Even though we are empty space, even though we are ghosts, we interact, we affect each other, we push and we pull. And there is one final mind-blowing detail from Feynman's lectures on this topic. We talked about how empty the atom is, the gnat in the stadium, the void. But Feynman reminds us that the space isn't truly empty. It is filled with fields. In quantum electrodynamics, the empty space between the nucleus and the electron is buzzing with activity. We said that electrons repel each other. But how do they repel? How does one electron know the other one is there? They talk to each other. They exchange particles. They send virtual photons back and forth. Imagine two people skating on ice. One person throws a heavy medicine ball to the other. When the first person throws it, the recoil pushes them back. When the second person catches it, the impact pushes them back. By exchanging the ball, they are pushed apart. They repel. Electrons do the same thing. They are constantly throwing invisible particles of light, virtual photons, at each other. You move back. No, you move back. The space between your hand and the table is not empty. It is a blizzard of virtual light. It is a chaotic storm of information exchange. So the void inside you is actually a chaotic ocean of energy. You are not empty. You are full of activity. You are full of light. The darkness inside the atom is actually alive with the exchange of forces that keeps you intact. So the next time you walk down the street, feel the pressure on your feet. Feel the solidity of the pavement, but remember the truth. You are walking on air. You are a being of pure energy, suspended in a web of forces, navigating a universe that is mostly nothing, yet somehow, miraculously, feels like everything. Solidity is an illusion. It is a trick of the light. It is a lie told by your electrons to your brain, but it is the most convincing, beautiful, and necessary illusion we have. It is the illusion that allows us to stand.